Okay, so good segue from Paco, because yesterday I used Jupyter Notebook, and today, yikes, yes, I always start you guys off with a bunch of code and command lines here. So the title, I forget the title of this talk, but I think it's about real-time recommendations. So this is something, when I traveled around Europe last year, it was one thing people were asking quite a bit about. So let me zoom in here. This actually is related, just a quick plug, I'm doing a workshop tomorrow at the Biva offices where we're going to be building this on the left. Actually, let me just zoom in the whole thing here. If you guys, for details, go to pipeline.io, and yeah, you can sign up there. But so essentially, what we're going to do today is a live demo. You're all going to take out your phones or your laptops, and we're going to run through. We're going to simulate a fake dating site, kind of funny, and send in ratings. We're going to rate people. It's just like American actors and actresses. Those ratings go into Kafka. There's going to be two paths that we're going to talk about. There's kind of the slow, boring batch path. So that's going to be this sort of red continues on, and these ratings go through Spark streaming, and they go into Cassandra. And then this data scientist person, today we're going to use Zeppelin, is going to generate a model, which is matrix factorization, alternating least squares from Spark, and physically deploy it out. It's going to sit behind Redis and Netflix open source, similar things to what I talked about yesterday. And then those recommendations you'll be able to see in the same UI that's on your phone. So that's the boring path. So we'll do that real quick. And then we'll do the fun path. So this is what everyone wanted to see last year when I was floating around Europe, and I've since built it. So we're going to go this purple path, which is incremental matrix factorization, essentially. So I'll talk more about it, but throughout every batch window, and batch, this is in terms of Spark streaming batch. So I've got it set up, I think, every 5 seconds or 3 seconds or something. We're pulling data from Kafka. So that's the latest of the ratings that have gone in from your app into Kafka. Every 3 or 5 seconds, whatever, we're going to run gradient descent, right, like mini batch gradient descent, and make small little changes to the weight vectors that we had established on the big batch, right, that we did before, the slow path. And so throughout each batch, this is very similar to how Netflix does things. That was my former company a couple years ago, where they generate at like midnight. They'll start generating the big batch historical recommendations. Store that into Redis or Memcache or something. And then so that's sort of the like offline batch, and then that might take 6 hours, 8 hours. So now it's 8 a.m., and people are starting to watch videos, children starting to wake up, and we want to start to capture the near real-time trends that are happening. And so this continues throughout the day. We make the small little changes. We can adjust, these recommendations in like near real time. And then at the end of the day, we sort of blow those away and recreate from all of the historical data again, okay? So that's the context. This is what we're going to build tomorrow. But today, I'm just going to run through it real quick so you can all see it. Okay, so the batch, if you would, let me just double check that all the services are running. I think they are. Yeah. So just to show you guys these. This is the live Spark cluster that we're using. We have Zeppelin. That's the notebook that we're going to use. We have the boring path right here. It's just Kafka going into Cassandra. And then here's the fun purple path right there. So these are physically two Spark streaming jobs that are listening on the same Kafka topic, okay? So those two jobs map exactly to these two. And all the code, of course, is public. This is all open source under Flux Capacitor /pipeline. I actually have the physical names of the Scala classes right here that are powering these if you feel like going into GitHub and looking. Okay, so let's do this. Oh, and then I've got a couple bonuses too. I'm going to show you guys Presto real quick, which is sort of like Spark SQL, but doesn't have, I guess, so per query with Presto, if one worker node dies, that whole query dies, right? So Presto is good for sort of the intraday, right, like ad hoc analytics, right, like versus Spark SQL, which is what you would run overnight to actually generate all of your, right, like recommendations, because that can like tolerate failures within nodes. So, but I'm going to show you something cool, which is Presto querying Kafka live, okay? Not many people know about this with Presto. Spark SQL, as of 2.0, 2.01, 2.02, has this concept called structured streaming. It's kind of a goofy name. I don't know why they call it that, but basically gives you the ability to run SQL on streams. I've never gotten it to work personally. I think Spark 2.02 finally has a Kafka connector, so that's something to look forward to. So let's start off here. If you guys could go to, let me show the link here, demo. If you could pull out your phone or whatever, go here. I'm not tracking anything. Yes, I know, right? Like you Europeans like your privacy, you know. Yeah, we Americans enjoy sharing our dark, dirty secrets of where our cookies. So go there, and you should be presented with, the fun code name for this is Spark After Dark, because it's a dating site, so it's supposed to be seedy and underground. This is just an anonymous JavaScript ID that I have here. That's just to tie things together here in a little bit. So just pick, these are 15 American actresses. Well, yeah, I guess not specifically American actresses, but these were, I think, the top 30 actresses and like actors, yeah, top 15 of each off of IMDb, some list I got. So you can choose them based on anything. Choose them not necessarily like attraction, but maybe you want to have coffee with them. And feel free, right? Like we're all open-minded people here. Yeah, I live in San Francisco. I have no problem selecting same sex, especially if I'm just going to get coffee. So I'm going to pick a couple. I always tend to pick Sofia Vergara. She's right there. That's just a personal preference. You guys don't have to choose her. Don't worry. Okay, and so as that's happening, we're actually collecting, let me show you guys this. So this would be kind of fun to show, I guess. Yeah, this is all backed by Docker, this one's running on Google Cloud, I believe. Oops, surveying. So this is all going through Kafka. All right, so as you guys are clicking, the ratings are coming through. So I'm just tailing the Spark streaming log file right here, just to show you guys that this is actually happening. This first column is the anonymous ID up here, so some of you might recognize it. If you see yours going through, I'm 4544. The second set, this is a tuple. This is so this is the payload actually going to Kafka. Yes, the reason why this is duplicated is because we're using the user ID for the distributed hash key, right? Because Kafka is a distributed, right, like queuing system. When you pass it a payload of here, this is the rating, you want to choose some key that's going to evenly distribute, these messages around the Kafka cluster so that there isn't just one hotspot. So that's why those are duplicated there. That's not a bug or anything. So each actor, I think, is 1001 through 1015, and then actress is 9001 through 9015, or it could be backwards, I can't remember. If you roll over one of these, you should see it in the JavaScript. Yeah, so it looks like females are 9001 down, way down at the bottom. Okay, so, and then one thing, and so there's no way to do thumbs down. Yes, I was trying to build Tinder, which is actually pretty popular here. I've come to find out the last couple days. I might have a date or two set up this weekend, we'll see. But because I'm trying to keep everything positive, and because I didn't bother to I couldn't find a thumbs down that looked fun, you can only select thumbs up. So essentially, you're always rating positive when you're rating. And that last field here, this is used for the geo-resolution. So one more thing that we do inside Spark Streaming is actually take the host name and convert it into city, right? And because this is Google, and because I'm actually using the server IP and not really where the browser's coming from, this always comes up as Mountain View, basically. Like California. So, okay, so it looks like ratings are still coming in, but that's okay. So I'm 4544, right? Okay, so again, just for context, we're here, we're inside of this Kafka Cassandra. This is writing out to Cassandra, and the data sits there. So now we're going to become data scientist person and use Zeppelin and actually start to analyze this. So I have a notebook here. Let me make sure we're connected. So here, we're just going to generate top K. This is a form of a model. It's a pretty straightforward model, just top K. So let's see who we all picked here. It looks like Morgan Freeman, Sophia, all right, she's number 2. That may have been me stuffing the ballot a little bit, pressing more and more, which I wish I could have done with Hillary Clinton last week, but they stopped me. Looks like Johnny Depp. Okay, so let's go to the next notebook. So here's where things get in. Oh, and so now that we've actually done that, we should be able to, in your app, let's see, global top 5. Boom. So these are the same 5 people that we just saw, right? Okay, so this says wait for Chris, that's me. We're going to do notebook number 2. So this is where things get interesting, and I'm going to spend a minute or two on this because there's some pretty cool stuff. So matrix factorization. So picture, if we take, so this is the sort of user to item, right, like matrix here, the rating matrix, right, like again, we can't do 0, but just kind of, right, like work with me here. For the items, these are the actors, actresses. We're going to run Spark's matrix factorization called alternating least square, which is going to do 2 things. It's going to reduce the dimensions and create 2 separate matrices that, when multiplied together, give you as close of a, right, like an approximation to each of these values that are known. So that gives us a couple things. That actually gives us the ability to fill in the sparsity, right? Because once these are full of 0.1, 0.6, whatever, we can actually then, right, like multiply, fill all these in, and then when this third user, 0, 1, 2, this third user logs in with the new values populated, we just sort those, and then we can show the user those recommendations. So what's interesting is that these recommendations are purely based on this collaboration. So there's no metadata here. There's no which movies they've been in or the types of movies or if they have dark hair or light hair. It's purely based around this group right here. So these values end up being sort of hidden features, right? Yeah, these are what are like commonly called latent features that's in this particular collaboration. This whole concept came out of the Netflix challenge a bunch of years ago. I think it started in 2006, it ended in 2009 with 500 plus algorithms that were then ensembled together. Was not computationally feasible, especially in 2009, especially before Netflix moved to the cloud. But this was a big, huge advancement here was this collaborative filtering. So this has powered Netflix's recommendations for years and years. It's very parallelizable, right? Which is why Spark loves it. You can sort of tile this matrix, right? And factor separate tiles and then aggregate them together at the end. And it's basically as large of a cluster, right, that you can afford, the faster this will happen. So, yes, I mentioned we get recommendations from this way now. We can sort, but now we can do two other things too. We can actually do, because we can represent each user by this new vector, right, of floats or doubles, whatever, you can now find user-to-user similarity, right? So you can actually do brute force cosine similarity, start with this guy, find all the people that are similar, or the top 10 people similar, figure out what that other person has watched, figure out the diff, and then start to recommend movies that you haven't yet seen that these similar people have seen. So we have user-to-user similarity, we have item-to-item similarity. So these are the items. So these are, in this case, the actors, actresses, but if we take movies, so we can find similar movies, like items by taking, start with this one and then compare to all the other ones. This is very expensive. This is a Cartesian, all pairs join. There's ways to simplify that. There's approximation techniques like locality-sensitive hashing, things like that to sort of simplify the calculations, right? These are all approximations anyway. So, but the good news here is that we've sort of reduced the dimensions, so these calculations aren't, the entire width. And when I joined Netflix, we had 20 million users. So we had, 20 million down this way, and we had 30,000. Which is really small, right? Like items this way. So now that number, I believe, is about, I think, 80 million, 90 million down, and I honestly don't even know how many movies they have now, especially that they're global. Okay. Yeah, so we can do item-to-item similarity, and this is pretty much how Amazon can serve up staples with stapler and things like that, right? But now we can also do k-means clustering, right? So we can cluster items together too, just like, so we can do the same here with users. We can actually start to cluster users together. Typically, they would be like the binge watchers, because you know how Netflix releases a whole TV series sort of at once. And so we would track these, binge watchers, and we would market to them, like similar binge type of TV shows. But yeah, these items get pretty interesting. So let's take movies. So now we're clustering not based on metadata, right? Like again, it's not like a Western movie or comedy or like documentary. This is specifically this, right, like collaboration. So I'm going to show you guys actually some of these that surfaced at Netflix. So typical genres would be, documentary, romance. These are the obvious ones, boring. These are the ones that came out of the sort of hidden features, right? So I think my favorite here is the Canadian revenge, like gory Canadian revenge movies. Yes, I like anything Canadian because it's just funny, let's see. Raunchy mad scientist comedy. Dysfunctional family. So this took a human to actually go in and put, labels to these things, and it's down to the ages between 11 and 12, that kind of thing. So when you're doing the k-means clustering, it's not really obvious where you stop. Like you can always continue, to use more k, use less k, whatever. So, but yeah, this is what they came up with. And like depending on which test cell that when you log into, like Netflix, you may or may not see these things. You might just see the boring ones. So like not a lot of people actually see these sometimes. Okay, so let's run this. When this is done, I probably should have ran it before. So here we're actually pulling from Cassandra. Just to give you guys a quick view, this is Scala. Here's the actual meat of this algorithm here. So we're saying rank 5. If it was actually going to match my diagram, it would be rank 4. I just got lazy there and stopped adding columns. But so this is the new dimension for these two new matrices, the user factor matrix and the item factor matrix. So when this algorithm is done, and then you can say whether or not these are the implicit preferences, right? So the implicit versus the explicit, this is sort of a feedback term, right? Like a collaborative filtering feedback term, meaning what type of feedback is the user giving me? So the explicit feedback is when you actually rate something. So the old, or the current, I guess, 5 stars on a movie, or you selected the person, that particular actor, actress. That's an explicit feedback. For the implicit, that would be things like, how far did you scroll down reading the movie? Like did you actually, how far into the movie did you watch? Sort of the softer type of feedback. And so the way I like to think of it is the explicit feedback is when you know that you're giving feedback to the system, which is probably why it's called explicit, versus the implicit, which is just loads and loads of like searches and things like that. Just sort of how you are interacting with the actual app or the device or the Xbox or whatever you're using. So the math changes a little bit when it's implicit versus explicit. Let's see. Here I'm attempting to do some deduping. I actually don't know if that's working. And so all of this ends up going into, let me just kind of tie this back. So, again, we're data scientist person here. We're actually doing this by hand, kind of testing things out. One of the things we're doing with Pipeline IO is right, like trying to make this easier. Paco, like talked before, was kind of sort of treating Jupyter, these notebooks like middleware, right? So it's not really just a notebook anymore, but there's actually going to be more things happening behind the scenes. So that's exactly what we're working on, the ability to deploy these out to production. In the case of recommendations, what we're essentially doing is just building up a new table, right? Let me show. We're essentially building up this matrix, but in a table form. So, think of the primary key would be the user ID, and the columns are the top 100 recommendations kind of thing. So we're using, and I believe Netflix is still using Memcache for this, but here we're using Redis. So we're actually going to populate Redis with the results, which makes it nice and fast. We're using this project out of Netflix called Dynamite, which I mentioned, I think, in the panel yesterday, where it's essentially, it's based on the Dynamo paper, right? The famous Amazon Dynamo paper, which is what DynamoDB is based on, which is what, right, like Cassandra is based on. So Netflix, being a huge Cassandra shop, wanted the same kind of semantics, right? Like they wanted the ability to tune the consistency versus the availability versus the network partitions, right? Like that kind of stuff, but with Redis, right? Like with an in-memory. So they have plugins for both Redis and for their legacy Memcache. And so essentially when you log in, and get your recommendations, there's no disk involved at all. This is very expensive. Not a lot of people can roll like this. This is why you guys have to pay the €8 or whatever instead of, I don't know. Yes, €8 doesn't seem like a lot. But Yeah, so they can serve up these recommendations very quickly. So we're mimicking that here. I think that's where it was. Here's the dynamite. We're essentially adding all of. With dynamite, you can actually, so just think of dynamite as Redis, right? In fact, this is an exact Redis API call, the Z-add, if you guys know the sorted sets. When you're adding things to Redis, you can use this like data structure called sorted set, where you give it the value to sort on, yes, as you put data in. So here we're actually giving it the new prediction, and then giving it the item ID. And that's for this particular user ID, right? Yeah, so essentially, the next time this user logs in, it's going to go into Redis and say, get me the top 10 or the top 100. And here I'm just testing it. So actually, now that I've run this, in fact, some of you might have already done it. So yeah, just real quick. One cool thing, too, about this model when it comes out of Spark is that you can actually get access to the user factors and the item factors. So this is what we're going to use for the real-time situation, right? So we're going to build upon these separate like factor matrices and then make small little changes. And so again, I think actually I show, yeah, so it's just as easy as calling model.userFactors and then model. So this is actually the user ID, and then those, in my diagram it was 4, but here it's 5 doubles. And then similarly with the items. So it's the item ID, so this would be the top right, and the user one before that we looked at would be the bottom left factor matrix. And so keep in mind that if you multiply, if I'm trying to predict the confidence that this particular user would like to watch a particular movie, I would take that user ID's, this vector, and I would call dot product on, let's say I was going to compare it to, I can't remember who 1001 is. I know 1006 is Tom Cruise. So yes, I would do the dot product of those two, and then that gives me some scalar, 0.96, something like that. So the cool thing is that Spark has done all this for us. They've literally done all of those dot products for us and have sorted everything on our behalf. But for the real-time case, I actually want those separate factor matrices because we're going to start to use gradient descent to make changes to them as more and more batches come in of ratings into Kafka. So I think this is actually, yeah, so here I've got a sample user, 21619. I'm actually getting out, I'm doing just what I described, which is get the vector out for that user, get the item factor vector out for Tom Cruise, and I'm using JBLAS directly. I'm calling the dot product. That gives me a scalar of 0.96. So now this is based on this collaboration. So this value is different. Yeah, so this value will be different tomorrow, for example, and it's different each group that we do this for. Okay, and we're storing the user factors and the item factors into Redis through Dynamite, so we can use this later. Okay, I've got another one. So that one I showed. Okay, I mean, from here on out, we should just be able to use the UI. So now, wait for Chris. Chris is done. And these are my personalized recommendations. I think, is my deduping working? No? Yeah. I keep revisiting it, and then I break it, and then I just revert the code or whatever. Anyway, so these would be personalized recommendations. Cool? Yeah, did it work for you guys? Thumbs up? All right. So now let's do the cool one. Up till now, this has been boring. Not classify, this would be real time. Boom, boom. So just add /realtime, HTML. So yeah, go to that one, do the same. In this case, I'm not involved at all. Data scientist person has gone home. They worked all night till 8 in the morning till their job ran. And now they're just relying on the machines to do the real-time recommendations, okay? So this is the purple path here. So this is where we're actually training in real time. This is called like online learning, incremental learning. Scikit-learn has something called partial fit on a lot of the linear models. And this is what's happening here. So if you want to look at the code, you can go in there. And so this is continuously recalculating these things. So actually, I want to show you guys something cool. So those are the ratings coming in. One sec here. Is it showing anything? I might have to restart the job, but one sec. So this is recalculating both the item to item. Okay, yeah, it's not showing that one. The recommendations. One sec. Let me kill this incremental one. Might need you guys to click again here. Where am I at? 5 minutos, okay. Okay, so I'm just restarting that second. All right. Okay, I mean, yeah, this will take a few seconds to restart. I have to restart Spark. Oh, we got something there, okay. Yeah, so essentially we're just recalculating with every batch that comes in. All right, so let me show you guys real quick the Presto fun. So Presto supports actually multiple connectors. You can query Cassandra, of course. You can query, the normal map, right, like HDFS and all that. But here we're actually querying the key and the message directly from, or on a live Kafka stream. So these are all those same things here, and you can, run your queries and all that stuff. So yeah, just keep that in mind. Presto is pretty cool. Yeah, Netflix uses Presto pretty heavily for the intraday stuff. Right, but again, it doesn't have the fault tolerance on a per query basis that Spark does. Performance, the Netflix guys have seen performance much better than Spark SQL. My own testing, because I don't know how to tune Presto very well, I've actually seen about equal, even Spark SQL being a little bit faster, especially Spark 2.0. But the Netflix people swear by it, so they must know how to tune it better than me. And one last thing, this is kind of fun. This is along the lines of recommendations. And it's kind of related to the creepy dating site that I've been describing, Spark After Dark. So imagine being able, on Tinder, you swipe right, you swipe left, right? You swipe right if you're attracted to the person. There's no, words. You don't read words or anything in this particular dating site. It's all physical, which is pretty bad. But so, right, imagine being able to train the app in the type of eigenface, for example, right? So the more people, it usually takes about 150, 160 swipes, where the system, and this is not using neural networks, right? This is just pixel, so all the faces would have to be, pretty close to aligned, right? But in this, fantasy world where all the faces are all aligned, you can actually start to kind of pick up, the width of the eyes and, things, the distance between nose and mouth and things like that, okay? So using eigenvectors, that's why the kind of fun name when you use this technique for faces is this term eigenface. So we're doing a little bit of normalization. The data set that I'm going to show you guys is actually this fun labeled faces in the wild. Not sure if you guys have seen this. It's 13,000 images. 1,600 people, and it's, George Bush, I think. George W. Bush is one of the more popular, things like that. So just kind of getting to the punchline here, we grayscale them just to simplify the calculations. We reduce them from 250 by 250 down to 50 by 50, just using normal Python techniques and some. And so here's sort of the top 8 principal components in this particular data set. So I've run through. Now this gives us the ability to now project all the 13,000 images into this new 8-dimension space, right? So this is, those vectors. So we simplified them from 250 by 250 down to 50 by 50. When we flatten each of these pixel vectors, they're now 2,500 wide. So now we can take a 2,500 wide pixel vector and get that down to 8. This is a bit coarse. It's not, the most accurate, but it simplifies the math for this. And then let me jump to here. So the fun one, I for some reason love Tom Cruise without really knowing it. I've seen every one of his movies. I don't know why. But so yeah, let's start with Tom Cruise. So let's say, I've at some point swiped right on Tom Cruise, and now I'm looking to recommend people that look similar to Tom Cruise based on these eight dimensions, right? So we run the math, and here's the. Someone actually said it's probably the squishiness of the face, the nose to mouth. Kind of fun. Candace Sutton. So we have yet another woman. Gerard Schroeder. And Yuri. Yeah, does anyone know this guy? First, if you guys know, I've got a TensorFlow sticker for you for your laptop. Yeah, shout it out. First astronaut to marry someone from space down on Earth. No stickers for you guys. But yeah, apparently, so I actually think he looks the most like Tom Cruise, personally. And then Cheryl James. So we have 3 women and 2 men. I would not use this particular algorithm for your dating site if you do go, but it's a good starting point. So the next version of this next year, if I get asked back, will be neural networks, and we'll actually try to make these a bit more accurate. So. Any questions? We out of time? Just come find me. Thanks for your time.